Hello guys, welcome back to my YouTube channel. Today we are going to solve day 17 problem on LeetCode. If you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. So this is a medium level problem in which we have to find the furthest building you can reach. Okay, so here in this problem we are given with an integer array heights, and it is representing the heights of the building and some bricks and some ladders. Okay, so you are going to start your journey from building 0, okay, and move to the next building by possibly using bricks or ladders. Okay, so you can use bricks or ladders. Okay, and while moving from building I to I plus 1, if the current building height is greater than or equal to next building height, then in that case you do not need a ladder or bricks. So obviously, let's say these two are buildings. Okay, this is building 0 and this is building 1. So here the height of this building is smaller than this building, right? Height of this building, that is at index 1, is smaller than the height of the building which is at index 0. In that case we don't need any ladder or brick to move from building this A to building B, right? So we don't need any bricks or ladders. We can directly jump if both the buildings are of same height, or if the building B is smaller than building A, then in that case we don't need ladder and bricks. Okay, so I hope that you guys are clear with this point. So let me read it again. If the current building height is greater than or equal to the next building height, you do not need a ladder or brick. You can directly move forward. Okay, now let's read the second point. If the current building's height is less than the next building height, then you can use either you can use one ladder or second building height and the current building height number of bricks. Okay, so here see, this is a building B and this is a building C. So here obviously building B is smaller than building C, so we can't directly jump. So we may need to use ladder here, or we may need to use bricks here. Okay, so now in this particular example, you see the height of building C is 7 and the height of building B is 2. Okay, so how many bricks you need if you want to move to building C from building B? So you need a 7 minus 2 number of bricks, that is nothing but 5. Okay, so here it is saying that hi plus 1 minus h of I, that is 7 minus 2 in this case. 7 minus 2 is this number of bricks. So is this number of bricks available? Yes, this number of bricks are available with us. So we can use this much bricks to move from building B to building C. Okay, so we can use either bricks or ladder. Okay, so here let's read this point again. If the current building height is less than the next building's height, you can either use one ladder or this number of bricks. Okay, so I hope that you guys are clear with both the points. In these 2 points we can move forward to the next building, and we have to return the furthest building index you can reach if you use the given ladders and bricks optimally. Okay, so this is the problem statement, and I hope that you guys are clear with the problem statement. Now let's go through the examples given to us. Okay, so this is the example 1. Okay, so I have already made a diagram here. So now let's understand this example 1. Okay, so here these are the heights of building. So initially height 4, then next building's height is 2, next building height is 7, next building height is 6, then 9, 14, 12, and bricks given to us is 5, and ladders is given to us is 1. Okay, so we have to just return the index. So we are starting from 0 index. So this building is at 0 index, this building is at 1 index, this building is at 2 index, this building is at 3 index, this building is at 4 index, this building is at 5 index, and this building is at 6 index. Okay, so here from building 0 to building 2, can we move without using bricks and ladders? Yes, we can move, because the height of building 1 is smaller than building 0, right? So this person now moves to this place. Okay, this building. Okay, and now from here position 1, building 1 to building 2, this person needs bricks or ladder. Okay, so option is given. Okay, here option is given. you can either use one ladder or this number of bricks. Okay, so we don't care about the height of ladders. Okay, so if we want to move from building B to C or any from one building to another building, we can directly use the ladder. Okay, we don't need to care about the height of ladder. Okay, but here in this case, let me use first bricks. So how many bricks given to us? 5. So if can I use 7 minus 2 number of bricks to move from building this building to this building? Okay, let's say this is a building A, this is a building B, this is building C, this is building D, this is building E, this is building F, and this is building G. So these are the names of the building. Okay, so if I want to move to building C from B, can I use 7 minus 2 number of bricks? That is total 5 bricks. So yes, 5 bricks are given to us, so I can use. So let me use 5 bricks. So here I am using 5 number of bricks. So I used 1 brick, 2 brick, 3 brick, 4 brick, and 5 brick. Okay, so here I have used 5 bricks. Now I am left with 0 bricks. Okay, now I am left with 0 number of bricks. I have used all the 5 bricks. Okay, to move from building B to building C. So now I am at this building. Okay, now can I move from building C to building D? Yes, because the height of building D is smaller than building C. Yes, so now I am at this position and I don't need any ladder or a brick. Okay, so now I want to move from building D to building E. So now I don't have any bricks left with me. So I have already used all the bricks. Now can I use ladder? So yes, one ladder is given to me. Okay, so I can use this ladder. So here I am going to use the ladder. Okay, so now here 6 to 9 I have used one ladder and I reached at this position. Okay, now I am at this position and I don't have any ladders with me or bricks with me, so I cannot move from building E to building F. Okay, so in this case I am at this index, right? Index number 4. And what is my output? My output is nothing but the index where I am at. Okay, so here in this case I have written 4. Okay, so I hope that you guys are clear. Okay, so here see explanation. We are starting at building 0. You can follow these steps. Go to building 1 without using ladders or nor bricks, since 4 is greater than equal to 2. Go to building 2 using 5 bricks. You must use either bricks or ladders because okay, something condition is given. Okay, here I read it. You must either use bricks or ladder because 2 is less than 7. And after that go to building 3 without using ladders. Okay, so these are the steps, explanation given to us. Okay, so here what we are applying. So here we are using bricks first, and in the end if we left with 0 number of bricks, then after that we are using ladders to reach to the next building. Okay, so we are saving the ladders for the end, and initially we are just going to use bricks. Okay, this is what we are doing in this example. But this approach will not work for certain examples. Okay, so this is a greedy approach. This approach is working for example 1. This approach is going to work for example 2, and this approach is going to work for example 3. But there is one more example here. For this example, this approach will not work. So okay, so here we are first using all the bricks, and later on we are going to use a ladder. Okay, so here let's understand this with example 2. Okay, bricks is 10, ladders is 2. So 4 to 12, how many bricks I need? I need 8 bricks. Okay, so here once I use 8 bricks, now I am left with 2 bricks. Okay, so now from 12 to 2 I can go without using any bricks. So now from 2 to 7, how many number of bricks I need? I can't use bricks because bricks are 2 and ladders are 2. So let me use ladder here. So I have used ladder here. Here I have used bricks. Here I have used ladder. And 7 to 3, yes, I can go without using any bricks or ladders. So here 3 to 18, yes, I can again use a ladder. Okay, from 18 to 20, I can use bricks. So because I am left with the 2 bricks, so I have used all the bricks here. So right now I am at this. From here 20 to 3, yes, I can go because this building is smaller. So here I am from 3 to 19, I can't go because I don't have any ladders or bricks with me because I have used 2 ladders and all the bricks. Okay, so maximum I can go till here. So what is the index of this 3? So this is 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, and 7 is the output. Okay, for this example 2. And same way in this example 3, from 14 to 3 I can go without using any ladder or brick. From 3 to 19 I can use the number of bricks. I need 16 bricks and I have used all the bricks. Okay, ladders are not given to us, so I have reached this 19. From 19 to 3 I can go because this building is smaller. So in this way, in this example 0, 1, 2, 3, so 3 is the output. Okay, I can use all the bricks. But here now let's understand this example. Okay, so here our greedy is going to fail. Okay, so now this is a building A. Okay, this is a building A, this is a building B, this is building C, this is building D, this is building E, this is building F, and this is building G. Okay, so bricks given to us are 4 and ladder is 1. Okay, so from building A to B, but let's say I'm going to use bricks first. Okay, so I am going to use bricks. So here I have used brick 1, brick 2, brick 3, and brick 4. Okay, so now I have reached at this building. Okay, so this is the building that I am here. Okay, so now once I reached at this building, I can move from building B to C. Okay, without use of any ladder or bricks, because this building C is smaller than building B. Okay, so now I am at this index. Okay, now from here building C to D, okay, I have used all the bricks, so I am left with 0 bricks here. Okay, I have used all the 4 bricks and I am here right now. From 1 to 2, from this one building C to building D, I don't have any brick, but in this case I just need only 1 brick. I just need 1 brick to reach from building C to D, but here I don't have any bricks. So but I am left with one ladder. So let me use one ladder. So I have used this ladder and now I am at this index. Okay, so now I am at this index, and from here building D, I just need 1 brick or a ladder to move to building E, but I don't have any ladders or bricks left with me. So I am at this index, so I have to return the output as 3 because I can't move forward. Okay, so but in this case output is 5 given to us. Okay, so now our greedy approach fails here because we are saving the ladder for the last step. We are thinking that initially let's cover whatever we can using bricks, and later on if we find any bigger building, then in that case we are just straightly going to use ladder in the end step. But here in this problem this greedy approach fails. Okay, so now let's understand with the case where we are using ladder first. Okay, where we are using ladder first in this problem. Okay, so let me okay, so let's say these are the bricks and this is the ladders. So okay, so let's say from building A to B I am going to use my ladder. Okay, so here I have used my ladder, so now my ladder's count is 0. Okay, from so now I am at this index. Okay, so after that from building B to C I can go without using any ladder or brick, so I am at this index right now because this building is smaller than my previous building. Now from building C to D I can use 1 brick. So if I have used 1 brick, so now I am left with just 3 bricks. Okay, so here I have used 1 brick. Okay, I have used 1 brick and I have reached at this index. Again I am going to use 1 brick to reach at this step. So here I have reached 1 brick and I am at this index right now. Again I am going to use 1 brick here, so I have reached at this index. Okay, so in total I have used all the 3 bricks. Okay, in total I have used the 3 bricks, so now I am left with just 1 brick in the end. Okay, I am left with just 1 brick in the end. Okay, so I have used 1 brick here, 1 brick here, 1 brick here. I have reached at this position. Now here I don't have any ladder, but just 1 brick left. So 1 brick, I can't use 1 brick to reach building G from building F. Okay, so here maximum I am at this index. So here what is the index? 5. So here this is my output. Okay, now many people will say let's use initially let's use ladder first, and then later on we are going to use brick. But that case will also fail. That case will also fail. Okay, so let's say this is the case here. Ladder is not given to us, so we can't we have to implement bricks first. Okay, but in some cases, in some examples, I think for this example, when we are going to use ladder first, so it is going to give same output, but there are going to be some examples. So let's try to understand with example 2. Let's see in this case if we use ladder first. So from 4 to 12 I have used a ladder. Okay, then after that I don't need any bricks, so ladder. 2 to 7, let's say I have used again my ladder. Okay, so now I am left with 0. Now 3 to 18, I need 10 bricks, but this case will fail. Okay, so now, okay, so let's do one thing. Let's understand if we use ladders first. Okay, with this example only. See here. Okay, so this is an example here. So here 4 to 12 I have used one ladder. Okay, 4 to 12 I have used one ladder. 4 to 12 I have used one ladder. Okay, so now I am left with just one ladder. So now 12 to 2 I can I don't need any ladder or bricks, so I reached at this index. From 2 to 7 let's say I have used one ladder again. Okay, so now I am left with 0 ladders. From 7 to 3 I can go without a need of anything. Now 3 to 18, can I use 18? I need 18 minus 3, that is 50 number of bricks, but I have only 10 bricks. So in this case I maximum reach at this 3. So what is the index of 3? 0, 1, 2, 3, 4. So but the output is 7, but in this case I have to return 4 if I use the ladders first. So this approach is going to fail. Okay, so greedy, we don't need to use greedy approach. And from all these examples, one thing is clear: we have to use our ladder whenever the height between the two buildings are max. Okay, so wherever the height between the two consecutive buildings is max, we are going to use ladder to save our bricks. Okay, so we are going to use ladder in those buildings where the height difference is maximum. Okay, so this thing is clear. So to solve this problem, what we are going to do, so let's say let's understand this with this example only. Okay, so let's say from A to B I have used 4 bricks. Let's say I have used 4 bricks. Now I am at this index. Okay, I have used the 4 bricks, so now I am left with 0 bricks and 1 ladder. Here from building B to C I don't need any bricks or ladder, so I have reached at this index. Okay, now from building C to D I have to check whether can I use my bricks or but no, because we are left with 0 bricks. In that case, here also I am taking a note that from building C to D I just need only 1 brick. So but I am pasting my ladder here for just a height, for just a difference of 1. I am pasting my 1 ladder here, and I have already pasted 4 bricks. Okay, if I want to move to C to D. So here he is regretting, this person is regretting. He is thinking that if I use a ladder where the height difference is max between the two buildings instead of bricks, in that case I can move forward. Okay, with just 1 brick. So here what is he going to check? He is going to count the difference between the consecutive buildings. So let's say he is going to use one max heap. Okay, in max heap he is going to store the difference between the consecutive buildings. So here 1 to 5, when he go from building A to B, what is the difference between these two buildings? 4. So this 4 is nothing but this 4 is the number of bricks this person is used at any point when he is moving from one building to another building. So here he, in this max heap, he is storing the difference where he used the max number of bricks for moving from building A to from building B. Okay, from one building to another building he used the maximum number of bricks. So here he is regretting that he is using the ladder. He's using his ladder for just this small height difference, but whereas if he has bricks available with him, then he can move more forward. Okay, so here what he is going to do, he is going to check the difference between C to D is 1. Okay, So difference between C and to D is 1, and he is going to check if the previous difference, wherever he get the difference between consecutive buildings, that is 1 and 5. Okay, so if the differences, previous differences, that is in max heap, if this difference is greater than the current difference that he is seeing. Okay, so current difference is 1. Okay, so in this case, yes, it is true. Okay, so in this case, what he is going to do, he is going to just replace the bricks that he used in the previous step with the ladder. So what he's going to do here, he is checking the difference, and here he has one ladder available with him. So he is going to send this ladder to previous step here. Okay, so now ladder is going to be decremented by 1. Okay, and he is going to recover the bricks here. Okay, so now my new bricks will be the bricks that I have stored in the max heap 4 and minus the difference between these two buildings. Okay, so what is the difference between 2 minus 1? Building D and C, so difference 3. So now when I reach at this position, so now my ladders becomes 1 less, so now my ladders become 0, because I have already used the ladder at this point, and my bricks, I am left with 3. Okay, because I have used 1 brick here. So that is why I am operating ladder as ladder minus 1, and bricks as the max difference that is stored in our max heap, that is max number of bricks that I have used previously. I am going to recover that, and I am going to just use the bricks from this step to this step. Okay, so now let's write the code for this, and I think when I'm going to write the code, you are going to be more clear about this problem. Okay, so now let's understand. So we are just going to write the same code, whatever we understand here. Okay, so first let's calculate the height. What is the length? What are the total number of buildings here? Okay, so these are the buildings height now, but these many buildings are there. Okay, so to count the height, okay, int n is equal to heights dot length. Okay, I am also going to explain line by line in the code. Okay, so just follow me. Okay, just follow along. So this is nothing but the total number of buildings. Int n is equal to heights dot length. Okay, now we are returning the index now, furthermost index date where we are at. Okay, where we are available furthermost index. So let me create one variable int I. Okay, in the end we are just going to return this. Okay, int I. So this is the index variable that we are going to return in the end. Okay, now we are going to iterate through each pair of consecutive buildings. Okay, so for that we are going to write one for loop for I is equal to 0. We have already initialized I. We declared I, int I is equal to 0, and I is going to be run from n minus 1 and I plus plus. Okay, so here one thing is that n is the height or length. Okay, so for this we are going to return the height as what? 1 2 3 4 5 6 7. 7 is the height. Okay, 7 is the number of buildings. Okay, and here my loop is running till 6. Okay, till this building. Okay, 0 1 2 3 4 5 6. Okay, so now after that I'm going to check for the difference between the consecutive buildings. So I'm storing that difference in this diff. Okay, in diff is equal to height of building, in diff is equal to height of building I plus 1 minus height of building I. Okay, so here this is a difference between any two consecutive buildings. Okay, now after that I am going to check if there is a positive height difference. Okay, if there is a positive height difference. So here I am going to check if difference is greater than 0. if there is a positive difference, then in that case only we need what we need ladder or bricks. Okay, if there is a negative difference, then we don't need to use any ladder or brick. Okay, so here if difference is greater than 0, then in that case if we are going to check now if we have enough bricks available. Okay, so if bricks is greater than equal to difference, if we have enough bricks available with us. Okay, so now if we are going to use brick here, so now my new count of bricks is going to be bricks is equal to bricks minus used bricks nothing but diff. Okay, bricks minus diff. And here one more thing, we are going to store this in our max heap. Okay, so now we are going to store the values. Okay, store the difference between the two consecutive buildings into the max heap. Okay, so for that I am going to use priority queue. Okay, so I am going to store the differences here. Okay, so let's create a one max heap to store the largest height differences. Okay, so write priority queue and differences are in integer. Okay, integer priority queue is equal to new priority queue and we are going to check the differences between let's say A and B are both are buildings, so it is going to store the differences. Okay, okay, so we have created one max heap. Okay, integer pq is equal to new priority queue, and here we are checking for the two buildings height A and B. Let's say two buildings, then B minus A we are going to store. Okay, so now if we have used the bricks, so now we are using the bricks for these two buildings, in between these two buildings from building A to building B. So that is diff is a difference, this number of bricks we are using. Okay, so let me store this, that is the height. Okay, in our max heap. Okay, so just write pq dot offer, add this diff is nothing but the number of bricks that we have used. This is a high difference, but if here we are using these bricks now, so that is why pq dot offer this diff. So here we have stored the height difference in max heap. Okay, now after that, this is one case. Okay, now after that we are also going to check if we don't have enough bricks but ladders are available with us. Okay, so else if ladders is greater than 0. Okay, if we don't have enough bricks but ladders are available with us. Okay, now inside this else if condition we are going to check if using a ladder is more efficient, then we are going to use it. Okay, so here if our this max heap is not empty. Okay, if it's not empty and the difference that we have stored in our max heap pq dot peak, okay, is greater than the difference that we are getting for the current buildings. Okay, for the current buildings, if that is the case, in that case we have to just create one top variable, and in this I am going to store the topmost element, okay, from our max heap. So here we are getting the largest height difference used before. Okay, now I'm going to recover the bricks. Okay, so bricks is going to be bricks plus top value minus diff. Okay, so here I have explained that somewhere top minus diff. So here, yeah, here top, how many bricks that I have used before, and the difference between the current buildings. So here 2 minus 1. Okay, so this is what we are doing. So here we are recovering the bricks, and also we are moving one step forward now to the next building. Okay, so bricks also I have used, and ladders I have to decrement the count. Okay, for ladders I have to decrement the count, and also the new number of bricks that I have used. Okay, so I have to store that same in our max heap. Okay, dot offer diff. So here we have stored the new height difference. Okay, now after that, in the else part, we are again going to decrement the ladders. So since we are using one ladder, even if it is not optimal, we are going to use it. Okay, here in this example, in this else condition, and after that this is else if we are completed, and in the end, in the else, if no enough resources or bricks or ladders, then we are just going to stop here. So here I'm just going to write break. Okay, and in the end we have to return the index of the last building that we have reached. Okay, so return I. Okay, so now let's run our code. So all the test cases has been accepted. Now let me submit it. So our solution is accepted. Okay, so let me go through the code one more time. So here we are using max heap, where we are going to store the maximum difference between any two buildings. Okay, and this n is nothing but it is representing the number of buildings. Okay, number of buildings. Int I is the index that we are going to return in the end. Okay, so this index is the index of the last building that we have reached. Then I'm running one loop which is going from this 0 index building to n minus 1, that is still here. Okay, till here, and after that I'm checking for the difference between the building at index I plus 1 and I minus 1. Okay, so if difference is positive, that is we have to use bricks or ladders. Okay, in that case, so here if we have bricks available with us, okay, if we have bricks available with us, then I'm going to use the bricks. So bricks is equal to bricks minus different and minus difference, and here in the max heap I am storing the number of bricks that I have used to reach building B from building A. Okay, to reach building B from building A. Okay, so here I have stored that difference, and in the else part I am going to check if I don't have any enough bricks available but my ladder's height is greater than 0. So inside this I am again checking if my max heap is not empty and the topmost element of my max heap is greater than the difference, current difference. So if this condition is true, okay, that is if the topmost, that is this 4, is greater than the difference between these two buildings, 2 minus 1, 1. Okay, if this condition is true, and in that case my top becomes this pq.pole, that is the topmost element of our max heap, and bricks I'm going to recover. So initially bricks that we have used, that is these 4, I'm going to recover them. Okay, and I'm minus it with the difference between these two buildings C and D. Okay, because I am going to reach to the next building now with the use of here I'm using ladder, and here I'm using the bricks for the difference between these two. Okay, so here I have updated the bricks, and now I am again adding the difference for the bricks that I've used. Okay, so this is going to be the my new max heap top element, and ladders I have decremented. And here in the else part, if this is not optimal case, okay, but we have to use the ladders. Okay, we have to use one ladder even if it's not optimal, so I am using that. Okay, and in the else part we are just going to break. Okay, if we don't have any ladders or bricks available with us, then we are just going to break. Okay, and in the end I am returning the index of the last building that we have reached. Okay, so I hope that you guys are clear with today's tutorial, and if you guys still have any questions, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you in the next video. Thank you. Bye bye.